Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little bit more GCSE higher level maths with Bathilda the Batty cat. Now today Bathilda is thinking of some numbers and she's giving you some clues. You're going to fill in a value for x in each of these thought bubbles and here are the clues. Bathilda needs a number x such that x to the power 1/3 is rational. We need another value of x such that x to the power 1/3 is irrational. And then we need some numbers that lie between 1.41 and 1.42. We need a rational number between those two and an irrational number between those two. Simple. Off you go. Right, let's have a look at those. First thing, of course, we've got to know what rational and irrational mean. The formal definition is that a rational number can be written down as the ratio of two numbers, a over b, as a fraction. What that means in practice is it's any number you can actually write down. Basically, that's it. Those numbers you can write down, these numbers you can't. Rational numbers include the whole numbers, because they can be written as like 7 over 1. So that's 7, that's a whole number. Easy fractions like 3/4, 3 over 4, things like that. Decimals, because things like 1.41 is 141 divided by 100. So that's a ratio. So any terminating decimals can always be written down exactly, so those are rational. Any recurring decimal, those can all be written as a ratio of two numbers. There's a special Batty Boffin video telling you how to do that if you're not sure. So any whole numbers, any terminating decimals, any recurring decimals, any fractions can all be actually written down exactly. Numbers that can't be written down exactly are things like the famous one is pi, 3.14, in fact it's on here. Here we go. 3.141592653589799323, and it just carries on. And it goes on and on for never ever, never terminates, never repeats, nothing changes in that, nothing, no patterns at all. So that's an irrational number. It is impossible to write down pi exactly. Other irrational numbers include quite a lot of square roots. The square root of 3, for example, is an irrational 1.7 something or other, and it carries on forever, never ends, never repeats, never terminates, nothing. So rational numbers you can write down exactly, irrational numbers you cannot, and they're almost always roots of some form. That brings us up to here. X to the power 1/3. Well, if you've seen any of the Batty Boffin videos on powers, hopefully as soon as you see that, you should go, negative powers are fractions, fractional powers are roots. It's a root. So x to the power 1/3 is the same thing as the cube root of x, the cube root of x. So we need some numbers, x, such that when you cube root it, it's a rational number. So the easy thing there to do is just pick a cube number. So something like 1 cubed is 1. So that means that the cube root of 1 is 1. The cube root of 8 is 2, a rational number. The cube root of 1,000 is 10. Those have all got rational cube roots. So for there, you could use 1, 8, 1,000. Any number that's got a nice normal cube root, anything you like on there. For this one, for irrational numbers, we want anything that does not have a nice cube root, does not have a nice cube root. So 8 has a nice cube root. 9 does not. So if we put the cube root of 9, it's 2 point something disgusting. We could have the cube root of 1,001, which is 10 point something disgusting. Cube root of pretty much anything. So the answers over here would be things like 1, 8, 1,000, things that have got a nice cube root. Answers here could be things like 9, 1,001, 82, anything that does not have a nice neat cube root. Okay, so that's the top ones. Now for the bottom ones, we need numbers between 1.41 and 1.42. Well, for the rational ones, that's dead easy. We can just use a terminating decimal. So something like 1.413. Anything you like, as long as it's bigger than 1.41, shorter than 1.42, and it terminates. Now here, is a little more tricky. You cannot use a terminating decimal because those are all rational. You cannot use a recurring decimal because those are all rational. You cannot use a fraction because those are all rational. You're going to need something like a root. Now you may know this one, it's a very famous one. The square root of 2 is 1.414 blah 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 blah. Fits neatly in there. If you didn't happen to know that one, what you could do is square that, and you'll find that that squares to something a little bit less than 2, that squares to something a little bit more than 2, and that gives you an idea that the square root of something in between them is going to fall in between. Okay, so square root of 2 would be the classic answer for that one. Okay, hope you had fun with that. I'll see you next time for a little bit more GCSE maths with Bathilda the Batty cat. See you next time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!